Good day. In this video, we are going to learn what is a matrix multiplication. How to multiply two matrices. Suppose we have matrix A and matrix B. The multiplication of matrix A with matrix B can be given as AB. Multiplication of two matrices is defined if and only if the number of columns of the left matrix is the same as the number of rows of the right matrix. Two columns and two rows. Multiplication of matrix A with matrix B is possible when both the given matrices A and B are compatible. Two matrices A and B are said to be compatible if the number of columns in A is equal to the number of rows in B. If A is a matrix of order m times n and B is a matrix of order n times p, then the multiplication AB can be performed, and the order of AB is m times p. We can say that matrices A and B are compatible. As we study, two matrices can be multiplied only when they are compatible, which means for the multiplication of matrices to exist, the number of columns in the first matrix should be equal to the number of rows in the second matrix. The order of matrices AB is m times p. For example, the matrix C and D are given. Determine whether multiplication CD and DC can be performed. If yes, state the order of the product of the matrix C. Order of matrix C equals to 2 times 1, and order of matrix D equals to 2 times 2. Multiplication of CD cannot be performed because the number of columns in matrix C is not the same with the number of rows in matrix D. Matrices C and D are not compatible. Let's check for the multiplication of DC. Matrix D with order 2 by 2 and matrix C with order 2 by 1. Multiplication of DC can be performed because the number of columns in matrix D is the same with the number of rows in matrix C. The product of DC gives an order of 2 by 1 matrix. How to get the order of the multiplication of two matrices? The order of a product matrix can be obtained by the multiplication of numbers of rows in the first matrix and the numbers of columns in the second matrix. We have the result of the product matrix with 2 rows and 3 columns. The order of the matrix is 2 by 3. For a better understanding, let's work through some examples. Calculate the multiplication of matrices A and B given as AB. Put the first matrix at the left-hand side and the second matrix on the top of the right-hand side. I try to draw a horizontal line in between the rows of the first matrix and vertical line in between the columns of the second matrix. This process will help in placing the calculated values in the respective positions. Now, we can understand the general process of matrix multiplication by the technique. Matrix multiplication indicates rows by columns multiplication. We multiply and add the elements as follows. We work across the first row of the first matrix, multiplying down the first column of the second matrix, elements by elements, then add the resulting products. Our answer goes in position A11 of the answer matrix. 2 times 1 plus 6 times 3. We do a similar process for the first row of the first matrix and the second column of the second matrix. The result is placed in position A12. 2 times minus 2 plus 6 times 5. Now, for the second row of the first matrix and the first column of the second matrix. The result is placed in position A21. Minus 4 times 1 plus 3 times 3. Then, we do the second row of the first matrix and the second column of the second matrix. The result is placed in position A22. Minus 4 times minus 2 plus 3 times 5. So, The result of multiplying our two matrices is as follows. 2 times 1 plus 6 times 3 equals to 20. 2 times minus 2 plus 6 times 5 equals to 26. Minus 4 times 1 plus 3 times 3 equals to 5. Minus 4 times minus 2 plus 3 times 5 equals to 23. We have the matrix of AB equals to 20, 26, 5, and 23. In this case, we multiply a 2 by 2 matrix by a 2 by 2 matrix and we get a 2 by 2 matrix as the result. Next, calculate the multiplication of matrix P with matrix Q given as PQ. The process is the same for any size matrix. Put the first matrix at the right-hand side and the second matrix on the top of the right-hand side. Draw a horizontal line in between the rows of the first matrix and two vertical lines in between the columns of the second matrix. Multiply across rows of the first matrix and down columns of the second matrix, element by element, then add the products. The first row of the first matrix and the first column of the second matrix. 3 times 2 plus minus 1 times 5. The result is placed in position A11. Do a similar process for the first row of the first matrix and the second column of the second matrix. 3 times 1 plus minus 1 times 3. The result is placed in position A12. The first row of the first matrix and the third column of the second matrix. 3 times 4 plus minus 1 times minus 6. The result is placed in position A13. Now for the second row of the first matrix and the first column of the second matrix. 2 times 2 plus 4 times 5. The result is placed in the position A21. The second row of the first matrix and the second column of the second matrix. 2 times 1 plus 4 times 3. The result is placed in position A22. Second row of the first matrix and the third column of the second matrix. 2 times 4 plus 4 times minus 6. The result is placed in position A23. The calculated results are 1, 0, 18, 24, 14, and minus 16. The matrices of PQ are 1, 0, 18, 24, 14, and minus 16. In this case, we multiply a 2 times 2 matrix by a 2 times 3 matrix and we get a matrix 2 by 3 as the result. Calculate the multiplication of matrix B and C, given as BC. Put the first matrix B at the left-hand side and the second matrix C on the top of the right-hand side. Only a horizontal line in between the rows of the first matrix can be drawn. There is no vertical line for the second matrix due to the second matrix has only one column of elements. Start with the calculation of the first row of the first matrix and the first column of the second matrix. 1 times 9 plus minus 2 times 4. The result is placed in position A11. Then, the second row of the first matrix and the first column of the second matrix. 3 times 9 plus 5 times 4. The result is placed in position A21. The calculated results are 1 and 47. The matrices of DC are 1 and 47. In this case, we multiply a 2 times 2 matrix by a 2 times 1 matrix and we get a matrix 2 by 1 as the result. Calculate the multiplication of matrices P and Q, given as PQ. Put the first matrix P at the right-hand side and the second matrix Q on the top of the right-hand side. There is no horizontal line for the first matrix because the matrix P has only one row. Then, we can draw two vertical lines in between the columns of the matrix Q. Matrix multiplication starts with the first row of the first matrix and the first column of the second matrix. 1 times 9 plus 5 times minus 1 plus 2 times 6. The result is placed in position A11. Do the similar process for the first row of the first matrix and the second column of the second matrix. 1 times 5 plus 5 times 0 plus 2 times 1. The result is placed in position A12. And the first row of the first matrix and the third column of the second matrix. 1 times minus 2 plus 5 times 4 plus 2 times 3. The result is placed in position A13. The calculated results are 16, 7, and 24. The matrices PQ are 16, 7, and 24. In this case, we multiply a 1 times 3 matrix by a 3 times 3 matrix and we get a matrix 1 by 3 as the result. That's all for this video. Thanks and see you.